Have you ever wondered where the water in our solar system comes from? It's a question that might seem simple at first glance, but it opens up a universe of fascinating possibilities. Water, that simple compound of hydrogen and oxygen, is the lifeblood of our planet, the key ingredient for life as we know it. But how did it get here? How did it come to be on our Earth, on Mars, on the icy moons of Jupiter and Saturn? There are many theories about the origin of water in our solar system. Some scientists propose that it was delivered by comets. Others suggest it was brought by asteroids. Some even believe it may have formed during the early stages of planetary formation. Each theory has its own intriguing implications, each one a piece of the puzzle in our ongoing quest to understand our place in the cosmos. So, are you ready? Let's dive into the fascinating world of cosmic water. The first theory we'll explore is the cometary delivery theory. This concept hinges on the idea that comets, those celestial bodies often referred to as dirty snowballs, may have played a significant role in hydrating our solar system. Abundantly rich in water ice, comets are thought to have been far more prevalent in the early stages of the solar system's history. Picture a cosmic snowstorm, with these icy bodies hurtling through space on a collision course with developing planets. As these comets impacted the planets, their icy payloads would have been released, potentially providing a source of water. It's a compelling image, isn't it? Snowballs from space, delivering the gift of water, the lifeblood of our planet. Of course, the cometary delivery theory isn't without its critics. Some point to the differences in the isotopic composition of water on Earth and the water found in comets. These differences suggest that if comets did contribute to Earth's water, they may not have been the primary source. Nevertheless, the cometary delivery theory presents an intriguing possibility. It paints a picture of a time when our solar system was a chaotic and dynamic place, with comets potentially playing a pivotal role in shaping the planets as we know them. But the cometary delivery theory isn't the only idea out there. Stay tuned as we delve into more theories about where the water in our solar system may have originated. Next up is the asteroid impact theory. Let's dive into a scenario where asteroids played the role of water delivery service to our planet. Now, asteroids might not be the first thing that comes to mind when you think of water, but they could have been instrumental in bringing water to Earth and other planets. Just like the comets, asteroids are remnants from the formation of the solar system. They're made up of rock, metal, and yes, ice. These icy space rocks could have collided with planets, depositing their water on impact. Imagine a period in the early solar system, a time of chaos and turmoil. Celestial bodies were forming, moving, and colliding. During this tumultuous time, water-rich asteroids could have been flung towards the inner solar system, impacting the forming planets, and thus delivering water. It's not just a wild speculation. Scientists have found that the water in some asteroids matches the water on Earth in terms of its isotopic composition. This means that the water we have on Earth could have originated from these asteroids. Of course, this doesn't mean that all the water came from asteroids. It's likely that multiple sources contributed to the water we have today. But the asteroid impact theory provides a compelling piece of the puzzle of how water ended up on our blue and green planet. So, asteroids could have been the rainmakers of our solar system. Now, let's consider the planetary formation theory. This concept suggests that our solar system's water may have been part of the original recipe, right from the get-go. Imagine the early solar system, a whirlpool of dust and gas swirling around a young, fiery sun. Now picture this cosmic dust and gas containing a significant amount of water trapped in the form of ice. In this theory, the building blocks of our planets, known as planetesimals, formed from this icy dust and gas. As these planetesimals clumped together and grew in size, they eventually formed protoplanets, and then, over time, the planets we know today. This concept proposes that water was present in the very fabric of these early planetesimals and was incorporated into the planets as they formed. Think of it like baking a cake. You wouldn't add the eggs after the cake is baked, right? The eggs have to be mixed into the batter and baked together with the rest of the ingredients. The planetary formation theory suggests that water was one of these initial ingredients mixed into the primordial batter that formed our planets. This theory is tantalizing, isn't it? It paints a picture of a solar system born with the seeds of life already embedded within it. But it also raises many questions. How much water could have been contained in this early planetary dough, and how much of it could have survived the hot and violent process of planet formation? Could our water have been with us from the very beginning? The interstellar medium theory takes us even further back in time. Picture a place that's not quite a place. It's a vast expanse, a seemingly infinite void, yet it's teeming with matter in the form of gas, dust, and cosmic rays. This is the interstellar medium, the space between stars and the birthplace of our solar system. Now, imagine the elements that make up water, hydrogen, and oxygen. These elements are abundant in the interstellar medium. Hydrogen, the lightest and most common element in the universe, is everywhere. Oxygen, although less prevalent, is still a significant component of the interstellar medium, primarily due to the life cycles of stars. The interstellar medium theory postulates that water formed in these spaces between the stars long before our solar system was even a twinkle in the cosmos's eye. As the gases and dust in the interstellar medium coalesced to form our solar system, this water was incorporated into the mix. It was frozen in comets, locked into minerals on asteroids, and trapped beneath the surfaces of newly forming planets. What does this mean for us? It suggests that the water we drink, swim in, and use every day may have originated in the vast and distant reaches of space. It's a humbling and awe-inspiring thought, isn't it? So our water may have come from the spaces between stars. The solar nebula theory suggests an even more local origin for our water. This intriguing theory proposes that the birthplace of our solar system, the solar nebula, could be the ultimate source of our water. Imagine a colossal cloud of gas and dust, swirling and coalescing to form the planets, moons, and other celestial bodies we know today. This is the solar nebula, a primordial soup of cosmic ingredients. But could this nebula have contained water? The answer lies in understanding the composition of the solar nebula. It was teeming with hydrogen and oxygen, the two elements required to form water. If the conditions were right, these elements could have combined to create water molecules. Further supporting this theory, scientists have discovered that the isotopic composition of water on Earth closely matches that of the Sun, our most prominent remnant of the solar nebula. This striking similarity suggests that our water could have originated from the same source as the Sun itself. But the real clincher lies in the protoplanetary disks observed around young stars, which are akin to our solar nebula. These disks, rich in water ice, suggest that the conditions in the early solar system could indeed have been conducive to water formation. So the water in your glass, the rain falling outside, the oceans that cover our planet, they might all trace their origins back to the birthplace of our solar system. Our water might have come directly from the birthplace of our solar system. Volcanoes might seem like an unlikely source of water, but hear us out. Picture the early days of our planets, when they were just forming from the cosmic dust and debris. In this chaotic environment, water molecules, among other elements and compounds, got trapped in the mantle of these forming planets. This is the heart of the volcanic outgassing theory. Now imagine these planets heating up as they mature, the intense pressure and heat within causing massive volcanic eruptions. These eruptions are not just spewing out molten rock, but also gases from the interior of the planet. And among these gases, you guessed it, is water vapor. The water vapor, once released into the atmosphere, cools down and condenses to form clouds. These clouds then rain down, filling up the planet's basins and low-lying areas to form our oceans. And voila, you've got a planet full of water, courtesy of its own volcanic activity. The volcanic outgassing theory is a fascinating perspective because it suggests that the water on a planet didn't have to come from a far-off comet or asteroid. Instead, it could have been locked away inside the planet all along, just waiting for the right conditions to be released. So, the next time you gaze at a volcano, Remember that these fiery mountains might have been more than just destroyers. Volcanoes might have been the fountains of our solar system. What if the water was always there, just below the surface? This question leads us to the subsurface hydration theory, a fascinating perspective on the origin of water in our solar system. This theory posits that water was not necessarily delivered to the planets, but rather it was always there, trapped within the rocky bodies of the solar system. Imagine a sponge soaked in water, with the water molecules hidden within its pores. Similarly, the rocky bodies in our solar system, including our own Earth, might have housed water deep within their structures. Now you may wonder, how did this water reach the surface? The subsurface hydration theory suggests that it was brought to the surface through impacts or tectonic activity. Picture a meteor crashing onto a planet's surface, or the ground shaking due to tectonic movements. These events could have forced the water up from the depths, releasing it into the atmosphere and eventually leading to the formation of oceans. Notably, this theory offers a compelling solution to the mystery of why our solar system's rocky bodies, Earth, Mars, and even the Moon, have so much water. Could it be that these celestial bodies were born with their water, so to speak? In the grand cosmic puzzle of where our water came from, the subsurface hydration theory provides an intriguing piece. The water might have been hidden beneath our feet all along. And finally, let's consider the most outlandish theory, alien delivery. It's a concept straight out of the pages of a science fiction novel, but it's one that some theorists dare to ponder. Could the water in our solar system have been intentionally delivered by advanced extraterrestrial civilizations? Consider this. The universe is vast, and we're still in the early stages of understanding its complexities. It's plausible that there are civilizations out there far more advanced than ours, civilizations that have mastered interstellar travel and possess technologies that are beyond our comprehension. The alien delivery theory suggests that these advanced civilizations, as an act of cosmic benevolence or perhaps a grand experiment, could have seeded our solar system with water. They might have directed comets laden with water ice towards our planets, or employed even more exotic methods, unknown and unimaginable to us. This theory, while highly speculative, stirs the imagination. It prompts us to consider our place in the universe and the potential for life beyond our own world. It's a reminder that the universe is full of mysteries waiting to be unraveled. Of course, the alien delivery theory is just that, a theory. We still have much to learn about the origin of water in our solar system, but isn't it thrilling to imagine that our water, the source of life as we know it, might have been a gift from the stars? So could our water be a gift from the stars? As you can see, the origin of water in our solar system is a complex and fascinating mystery. Each theory we've explored offers a unique perspective, a piece of the puzzle that is the origin of water in our solar system. The cometary delivery theory suggests that the water we see today was brought to our planets by icy comets hurtling through space. The asteroid impact theory, on the other hand, posits that ancient asteroid collisions could have introduced water to our planets. Then there's the planetary formation theory, which proposes that water may have formed during the early stages of planetary formation. The interstellar medium theory takes us even further back, suggesting that water might have originated from the cold, dense regions of space between the stars. Or perhaps the solar nebula theory is right, and water was part of the protoplanetary disk that eventually formed our solar system. And we cannot forget the volcanic outgassing theory, which suggests that water may have been expelled from the interior of planets through volcanic activity. The subsurface hydration theory, too, offers an intriguing prospect, proposing that water may be produced through chemical reactions in the mantle of planets. And finally, the alien delivery theory, though a bit far-fetched, proposes that extraterrestrial life forms might have brought water to our planets. Each of these theories is a testament to the ongoing nature of scientific discovery. They remind us that the universe is a place of infinite possibilities, where every answer we find only leads to more questions. They encourage us to keep wondering, to keep asking questions, to keep seeking the truth. And while we may not have all the answers yet, The search for them is a journey that's as thrilling as the destination itself. The mystery of where our water came from is a cosmic puzzle that scientists all around the world are working tirelessly to solve. Until we solve this cosmic puzzle, the origin of our water remains a mystery as vast as the universe itself. Before we wrap up this deep dive into the enigma of the origin of water, we'd like to remind you that the wonder of the universe is not just for scientists to explore. Each one of you, our viewers, are a part of this grand cosmic journey. By watching this video, you've taken your first step into a larger world, a world filled with mysteries to solve and wonders to behold. And if you're as captivated by these cosmic puzzles as we are, we invite you to join us in our journey of discovery. If you enjoyed this video and want to keep exploring the mysteries of the universe with us, please hit the like button and subscribe to our channel. Don't forget to click the bell icon to get notified about our latest videos. Have a theory or an idea about the origin of water? Or perhaps a question that's been bugging you? Drop a comment below and let's start a conversation. And if you think this video could spark curiosity in someone you know, do share it with them. Remember, every share, every like, every comment helps us bring you more content and helps us all in our quest to unravel the mysteries of the universe. So, until our next cosmic journey, keep looking up and keep wondering, because the universe is full of questions waiting to be asked, and who knows? The next big discovery could be just a thought away.